Hello friends, so today in this video we're going to discuss the fourth problem from the latest educational Codeforces round 108, problem named maximum sum of products. Like I haven't solved this problem during the contest, but like I've seen some code and then I got to understand that this is a very simple problem, it's not too difficult. I might have solved this during the contest also, but I'll tell you in simple terms what this problem is asking, and then we're going to discuss the implementation part. It actually states that you are given two arrays A and B, and then you can reverse or like you can flip out any contiguous subarray, like any contiguous segment. Okay, you can flip out in any of these arrays such that, or in the array A, sorry, such that after reversing out that subarray you have to maximize the summation of ai into bi over all the values of n. So like there is some initial value such that you can you can multiply like 2 into 1, sorry, 3 into 3, 2 into 2, 1 into 4 plus 3 into 2. This can be the original value, but you can choose out some subarray. Let's assume that in this example they have chosen 3 and 4, like this subarray starting from the 4th index to the 5th index. So as you can see, if you reverse out this part, then the array will become like this: 3 2 2 3 1, and then the new answer can be this 29, and that's the maximum answer. So you can like somehow reverse out any subarray from this original A array such that after reversing out you have to find out the maximum value of ai into bi addition over all these values of this number or this array. I hope you understand the question part now. First thing, you can see that the constraints are n is up to 5000, so which means that you can solve this problem in O of n square. Okay, so like whenever I see 10 to the power 6 or 10 to the power 5, it means that I can solve this in O of n or O of log n. But whenever I found out a solution of like 1000 something that, so then I can solve this problem in somewhat like O of n square or log n or something like that, log of n log n or something like that. So as you can see, now I can solve this in O of n square. Then what you can simply think over this problem is, like in such type of problem, the main crux can be, yeah, like the subarray can be of length like even size or odd size. What I mean by this is, let's assume that this is the 5 size arrays, like these are the two 5 size array A and B. Okay, then first what you can do here is, like in such type of problem, what you generally can do here is like first find out the answer for the original problem. So ai into bi, like a1 b1 plus a2 b2 a1 like a3 b3 a4 b4 a5 b5, and you can find out the answer as total. That's the initial total answer. Okay, then if you reverse out some subarray, then you are actually changing this total answer. Like how much total answer you are actually changing out. Let's assume that if you are changing out a subarray of size 1 starting, let's assume that this is the middle point and you are reversing out this subarray. If you are reversing out a subarray of size 1, then obviously it is not going to change my answer. If I'm going to change out a subarray of size 3 centered at this point, then actually I'm changing out these two elements. If I'm changing out these two elements, what is the new total answer? See, you can easily observe that the whole array is same, like this answer, and if there are more elements, those are same, only these two elements are changed. And what is the change? The original answer was this element was multiplied with this and this element was multiplied with this, but now this element is interchanged, so this element is multiplied with this, because after changing this will come to this place, and this element is multiplied with this. I hope you get the point. So it means that in this total answer you subtract out this part, which was multiplication of these two elements and these two elements, and add multiplication of these two elements and these two elements. I hope you get the point which I'm talking about. So that when you subtract out this part and add out this part, it is actually the new total summation when I flipped out this subarray. Okay, then if I again extend my logic and make a subarray of this size, now my total has actually changed these two elements. Now obviously when I flip out the other part, when I flip out this subarray, then actually this is multiplied with this is multiplied with this is multiplied with this, and this is multiplied with this. These twos are actually already changed and we have stored that answer. If I only change now this subarray, then only these are changed, and these are changes somehow. What we can do, I have a total answer, subtract out these summation of multiplication of these two, this two, and add the multiplication of this and this. And that's the whole logic. When you have, so that what we're gonna do here is, now if we will take out like two arrays, so the sub array what we're gonna reverse can be of odd size and even size. And as you can see, in this case always the length is odd size because I have taken one center element. So the subarray can be this of size 3, or subarray can be of size 5, and so on. But it can also happen that the subarray is, so as you can see now, in this case what we're gonna do, we're gonna take for every element in O of n square. I can do now. So for one loop I can iterate over every element. For every element I will take out, like I will form a subarray of odd length, one element before it and one element after it. Like it doesn't go out of bound, so we just take out, we just go to the next element. We just go out to the next element. Okay, when we take one element ahead of it and one element before it, this subarray is fine. So what we'll do, we will reverse out this two and find out if I reverse out this subarray, what will be the answer. Else I cannot make a subarray of size 5. So we'll move to the next part, which is this. Now I can make a subarray of this size. So what I have a total sum, I will just subtract out multiplication of these two, and add the multiplication of these two. Then I will find out the maximum among this answer. Then I will increment my subarray. And then what's the next point? Because I have already changed that, now I can change this 2 and this 2. Then I can increment, then I will go out of bound. So now I will again revert back to the original state, and then I will start from this 2. So this is the subarray, so just change out this 2. So in this case I am obviously like in every case making a subarray of odd length, and I am just finding out for every possible combination, because in O of n square we can find out. But in the next case can be the subarray can be also of even length. As you can see in the last example, we just flip out the last two elements. So it can be also that if I take out my I and j, so I will take out my I at this point, and so as you can say, then if I reverse out my I and j, my I is this and my j is this. Okay, one step before and one step ahead. So there is one counter. Let's assume that this counter is capital X. This counter is moving from left to right, and with respect to every counter I have two values I and j, which marks the ending and initial point of the subarray which I'm gonna flip. I hope you get the point. And this will increment. If there is some more space, there is no more space, so this will not increment, and we will go to the next point. Now my capital X will change to this point, and this is the I and this is the j. So like this is fine. So I will now again change my I and j, and this is fine. So I cannot change my I and j, so I will change my X now. And this is how you can make a subarray starting from I and j. But now if this will obviously always give me a subarray of length odd, but if I want to make a subarray of length even, I will make my X at this point. So I can be at this point and j can be ahead of this, like one step ahead of this. Okay, so this is the subarray now, and now as you can see, this is the subarray. The next subarray can be I is at this point, j is at this point. So in this case now every subarray is of even length. I hope you get the point. So we have to initialize the starting point, and then we just move I one step back and j one step back if they are inbound, and then just reverse out those elements so that we can get the new answer. And then in that case you can find every possible subarray of even length in one case and every subarray of odd length in other case in O of n square. So the total complexity will be O of n square for finding out all the odd lengths and O of n square for all the even lengths, and then you can find out the answer among all the possible answers. And that's the whole logic for this problem. Actually, I'll show you the code part now to even make it more clear. You can also look out the code in the description. You have taken the input of all the A and B. This is the answer. This is the maximum answer which we're gonna find. First, find out the total answer, which is the answer for the initial case, and this is the maximum answer till now. Okay. Then we're gonna move our I pointer of finding out all the odd length subarrays, starting from I equal 0 till n. Okay. So now we're gonna initialize my starting total with this answer, because that's the starting total. Now I'm going to initialize my left and right. So left is I minus 1 and right is I plus 1, which I've told you for finding out the odd lengths. Now if both are inbound, we're going to make a while loop, because this is one for loop, this is the other for loop, which is like a while loop, in which if both are inbound, what we're going to do, I will subtract out, as you can see, the initial pair. Initial pair is both of them both L and R, which was initial there in the total, because in the total we have taken all of these pairs now. So these pairs are there. So if I want to change them, I have to first delete out this pair and then add on the another like the new modified pair. So I have to delete out the old pair, which is a into like al into bl, which is like a of L means that the a of like the array A left pointer like the left block and the b pointer left block. We just multiply both of this multiplication and both of this right block multiplication have to be removed. So this is removing, and then we have to add the a block left block value and the b right block value, and the same for the a right block value and b left block value. You have to multiply and add them, and then this is the new value, and we have to maximize this answer. And then we have to subtract. My L will go one step back and right will go one step ahead. And then because this total is not changing, if we have some fixed value that like my capital X is at this point, I have found out one answer for this, then I want to increase my sub-array length. So as you can see, my total is not changing. This while loop is not changing. We're just incrementing my total counter value, and we're gonna updating my maximum changes what like maximum value which we can found out. And then whenever my range go out of bound, I will come out of this while loop, and then my total is again initialized with the starting answer value, which is the like, because now I am again with like a new fresh array in which nothing is reversed out, and this is my center point, and then again we start reversing out and forming out sub arrays of odd length. So this is the for finding out all the odd lengths, and this is for the even lengths, in which this is the same code, but now my L is at I and the R is I plus 1, which I've told you. And then we're gonna do the same thing, which means that the sub arrays of even length, like whether we have to delete out this pair and add out this pair, and then whether this is the maximum, and then increment my R by 1 and decrement my left by 1, and then again do the same thing, so that finding out for all the sub arrays for even length and odd length, and then like printing out the maximum among all the cases. And that's the whole answer, the full logic for this problem. If you still haven't out, you can mention out. I'll see you next one. Till then, keep coding and bye.